All right. Well, I work for a company called Shoebox. They're in Boston. I should say a little bit things about that company first, because it's actually relevant. This picture is from one of our summits that we have, because we have a couple of remote people here in Europe, including me. So twice a year we go to the States, somewhere close to Boston, and we all couple up in some sort of farm or whatever, and code. And Shoebox is the one place where entrepreneurs, lawyers, investors, and board members can come together to generate, review, approve, and execute company documents. It's a system of record execution and engagement built to simplify standard corporate legal processes. And if you wonder what that means, it means that it's a web application that will deal with all your legal documents. You can upload them, you can also sign them, and people get reminders that they should sign these documents, and it keeps track of them, and it keeps track of a lot of the information around it, especially when it comes to things like stocks. So the legal documents for buying and selling stocks within a company, this application will take care of that, and that way you always know who actually owns how much of the company. Things like this. Only for US companies at the moment, obviously, because other countries work completely differently. And at Shoebox, I have mostly been dealing with reporting, because you need reports, many reports. Which office is selling the most yellow telephones? How has shipping costs developed the last few years? Are we actually getting new customers faster than we lose old ones? Things like this. People have many questions. But you have a big database, and the database is extremely normalized. So it was designed by people who have taken university courses in how you design relational databases, and then you get very normalized databases with no data duplicating whatsoever. And you'll have some tables that may even only have a key and a value column, several of them maybe. So you get many complicated joins, and if you make a small mistake in the query won't take 10 seconds, it will take 10 hours. Or your data is in a NoSQL database, and you might have indexes, but not on the things you actually need to search for or filter on. And there's no reporting tools, because there is no reporting tools for NoSQL database in general. Definitely not for the obscure NoSQL database that your CTO chose because it was the hot database of the week when he started the project. You might have several databases, maybe even different types of databases. But anyway, you make the reports, and for the SQL database you have these elaborate SQL queries, and the NoSQL database you write a Python script that will export the data, and you write a script that will merge these CSV files, and you make a nice table and a nice graph, and your boss is happy. And the next Tuesday they want the report again, but somebody's changed the database schema, so your SQL query doesn't work anymore. And your boss wants the query now. She likes your report so much that she demands daily copies, but because of this complicated procedure in making the report, it takes you half a day to do a report, which means that full-time job would be making 2 daily reports, and that would be pretty boring. And the query takes an hour to run, and it makes the database so slow that people start complaining that the internet is slow because they don't know the difference between the database and the internet. And they go to the network admin, and he gets angry at you and stops bringing you coffee when he goes and fetches himself. And how do you get your coffee back? Well, of course, with a reporting database. That's what the talk is about. Reporting a database, normal databases is designed to be fast and useful for the software that actually uses them, not for reporting. So you have indexes on last name and first name, because that's what people use to find the customer that they're talking to, if they're sales representatives or if they're customer service. But they don't index which region of Poland that your customer belongs to, because nobody ever searches for that. But you need that index, or you want that index, because you need to make sales reports per region. So having that index will make your reports faster. So a reporting database is made to do reporting easy. It's not afraid of duplicating data. It can integrate data from several sources. And often, but not necessarily, it's read-only, i.e. you get the data that you want to do reports on and you stick it into a reporting database and you make the reports. And the next day you get new data and either you just batch add it or even just drop the whole reporting database and recreate it. So you don't sit and update necessarily the reporting database bit by bit. You can do, but you don't have to. It's better if you don't. And when do you need it? Well, if transaction performance is critical, so you can't modify the production database because it's going to get slower and the database guys don't accept that. Or because it's a commercial product and the commercial product actually complains, or you're the company that sold it to you refuses to give you support if you modify the database schema. Things like this happen. Or if you have multiple databases that you need, because then you need to merge the data first. If the reports are long running, because you don't want to accidentally make the production slow. Or if you need to massage the data, i.e. there's something you need to change in it before you make a report. The internal field names and values might not fit what the economics department expects, for example. You might have not one sales office in every region in Poland, but your internal split up might be completely different. Maybe even some regions are split up between different sales offices. And that information does not actually exist in the customer database. So then you have to add that when you massage the data. And how do you do it? Well, it should be a separate database, obviously. Don't put these tables into the production database. Preferably, it should be on a separate database server if you can. The updates of this should be as synchronous. As mentioned, there can even be batch jobs that do everything. That's the most common way of doing it. But it's important that when the production database updates, the production application don't wait for the reporting database to also get updated, because then it's going to get slower. Data must be rebuildable from the production data. This is only a copy of the production data. It's a changed copy that is easy to do reports on. The reporting database should not contain any information that doesn't exist anywhere else. And you should use a star or snowflake schema. And those look like this. Star schema, it's a simple schema where relations are only between the central fact table and the surrounding dimension tables. And in theory, the fact table should hold the measurable quantitative data about business or whatever it is you're looking at. And the dimensions are descriptive attributes related to that fact data. So, for example, the fact table can contain a list of all the sales you've done, while the dimension tables hold the information about the products, the customers, and which sales office that sold it, for example. So the fact tables are what you want reports about, really. You want to report about sales, when you need a sales fact table. You need reports about customers, you need a customer fact table, stuff like this. And it can be hard to know what's a fact and what is a dimension, and a lot of things actually are both. So in one star schema, you might have a customer fact table, and in another star schema, the customer is a dimension table. Which is why they should always end actually, either end in underscore fact or underscore dim, which is better than this example where they start with fact underscore. That's slightly annoying because your Postgres SQL command line will actually autocomplete for you. So you don't want everything to be called fact underscore something. You can also use a snowflake schema where you add dimensions, 2 dimensions, if your dimensions are very complex and if the data duplication actually gets problematically big. But I don't know how often this is needed. The important part is that dimensions never have relation to other dimensions, because that again makes querying complicated. There's one dimension you need. I don't know how well you can see this, but this is the date dimension. And this is because you can't make queries on date simply or easily. It's hard on a date field to say, I want everything up that is in the third quarter of 2015. So therefore, every time you end up with a date column, you should also have a date column that is only an integer that's pointing to one of the rows in the date dimension, where you have all this information about that specific date. What day of year it is, what day of month it is, what day of week it is. All this information. And you also have information that's usable for displaying the report. So for example, there's a column here called quarter_ordinal, which contains the text 3rd, i.e. third. And that kind of column is used for, in the nice little report you made, splitting the different quarters out. So it says first, second, third, that kind of information. What columns you want here is completely up to you. These are the ones we are using. They are quite overkill. There was a couple of there that I really didn't see the point of. Maybe I deleted them from the example. Yeah, day of week in month, right? That's a weird one. It's like if it's what week number it is within the month and things like this. I don't really know what you would need that for. So how do you update this database? Asynchronously, we said, well, the process of updating is called extract, transform, load. That's the process they use for any sort of data warehouse. Reporting databases is a type of data warehouse. And it sounds kind of obvious, right? You extract it, you transform it, you load it. How would you else do it? Well, there's also another procedure called ELT, extract, load, transform, which you use for data lakes. That's when you do data mining, for example. Then you stick all the data you have in the company into gigantic databases, completely unstructured, and then you try to dig data out of this gigantic pile. Then you do extract, load, transform. So it's less obvious than you think. But a reporting database is there to be easy to do reports with, so we transform the data before we load it. And these steps don't have to be done in the same place or same time. So how we do this depends a lot on our requirements. And you can, essentially there's two ways of extracting the data. Either doing it in batches or doing it when the data changes. Batches seems to be the most common. It's definitely the easiest. And extract generally extracts the data in a raw format, and you can very well extract all the data that you have, unless it's sensitive. Then the extract procedure also needs to select carefully what data it actually extracts. You can't just do a select all from a column and dump that out to a comma-separated file if you are selling French ticklers, because it could be a Catholic that bought one. That's a Python reference. So the most common way of extracting is in batches. It's preferable if you can do a dump of all the data that you have in a reasonable time frame. So then you can do maybe an extract every night when the database isn't heavily used. But you can also do it maybe every 15 minutes and just extract in a batch file everything that's changed. So you can do that also every night if your data is actually so big that you don't want to extract everything. We currently, it takes around 2 hours to do the extract procedure for us, but we are just in the end of a beta phase. We are hoping, obviously, that we're going to get a lot of customers, and if we get 10 times, 20 times as many customers as we have now, that means actually that it would take more than 24 hours to do the extract. So that's not possible to do it during the night now. And a big benefit to do it in a batch job is that the tools that exist generally do it this way. This is the way that, like, recommended to do it. So we're going to talk a little bit about Pentaho, which is an open source suite for doing reporting, and they have data integration tools, and they do it batch way. If you can't dump everything out, you need to be able to detect the changes somehow. And this also has drawbacks and benefits. The drawback is that you risk inconsistent data. You might do an extract, and somehow that extract never ends up being loaded into the reporting database. And this is one of the reasons where you have to be able to recreate it from scratch, but you need to dump the whole database and recreate it, even if it takes several days. The benefit is that you don't have any long-running main database usage, or at least the extract gets very much faster. And you need to detect the changes, and that's either by having timestamps on everything that needs to get exported, timestamp on when it was last modified, or you need to have sequence IDs if it's things that just get added, right? Or you can use database logs. Not all databases can do this, but many databases can actually log exactly which record in which table has been modified. And then you don't have any information of what it is there, but you now know which record that should be extracted. So that's also a way of doing it. And the other way, less recommended one, is to do update things on change. That is to somehow have some sort of hook in the application or in the database, because many enterprise databases support triggers and events. You can set them up so that there's a trigger when something gets changed and it writes something to somewhere. And that way you can get an event or a trigger, and you can handle this. And it's then important that the handling is done asynchronously, but with a database trigger it will be, of course. You can also use application events if your application internally sends events on modification. But then again, you need something asynchronous, like for example Celery, which is what we're using. And the benefit with this is that you get near real-time updates, right? You can do actually reports on what happened 15 minutes ago, or even less. Usually, of course, the reporting database is going to be within a couple of minutes of synchronization. So that's a nice thing, but usually you don't need that. The people that make reports are quite often happy with just having last month's data. The next step is transforming. That's usually very easy. In worst case, you can end up in a situation where you actually need to merge two big sets of data in such a way that you can't do it record by record. You have to actually load everything into memory, do the changing that you need to do and the updates, and then write everything out. And if it's so much that you can't even fit it into memory, you then have to actually create a temporary database, load it into temporary tables, do whatever you need to do and write it out. But that's pretty unusual. It's like theoretical. Generally, you can just go record by record through this file, which often is a comma-separated file, and do the modifications you need to do, and write them out. And lastly, you load it. Loading doesn't need to be separate from transform, because loading is so trivial, because you just need to load it into a database. So if you're actually having a Python script or something that does the transformation of data, it's fine if that Python script also writes it directly to the database. But on the other hand, that means the code gets slightly more complicated, so maybe it's just easier to write it out to a comma-separated file and then do a batch load. We don't really separate transform and load. And ta-da, you have a reporting database. You got all the data in, you can now make reports. And for that you need some sort of reporting tool. And I don't think any of the available open source reporting tools are any good. Most of them are not usable by normal end users. You generally need to be able to write SQL queries directly, and power users might be able to learn this quite simply or easily, but a lot of people will not be able to do it. The only open source tool that is aimed at normal mortals is LibreOffice Base for making reports, and it has some really nice features like this query editor where you can make queries without writing SQL. It's very good and useful and works fine with star schemas for reporting databases. It can, of course, do more complicated things too when it comes to SQL, but maybe it's not as easy to use then. But with a simple star schema, it's very easy to use. The reports, however, are generated by LibreOffice Writer, and they, by default, horribly ugly, so you need somebody who actually knows LibreOffice Writer well to make templates for this. And I couldn't figure out how to insert a chart. Seems like it's possible to do, but I couldn't figure it out. Next one of the ones I looked at is called BIRT or BERT, I don't know. And it's actually a plugin to Eclipse. And that's a fairly strange way to write a GUI tool. But, you know, Emacs, they're a good, has destroyed many things. Yeah. So why not build an operating system in Eclipse too? You can do that, sure. So we got BIRT here that involves no code editing except for SQL, which you have to write yourself. Otherwise it's a GUI tool, so it's a very strange Eclipse plugin. Its documentation is not very good, but you can use it. The default reports are not that ugly. But then again, have no help in the SQL query.
It's horribly slow.
Aha, it's horribly slow too. Yeah, I never got that far. I just decided I didn't really like it. Well, anything in Eclipse is horribly slow, but modern computers are fast, so it's not a big problem. And this is what we're actually using. We're using Pentahole Community Edition. There's an enterprise edition too. It's rumored to be insanely expensive, and since they don't write how much it costs, you know you can't afford it. So that's a good rule for any sort of thing. If you go buy a shop and they don't have prices, then you can't afford it. Or, I mean, you know, unless you have so much money that you know you can't afford it, no matter what it costs. Same thing for software. Don't get the Pentahole Enterprise Edition unless you're an enterprise company with infinite amount of money. The Community Edition is pretty good though, and it is not just a report generator, that's just one of the tools that exist in it. It has something called a Business Analytics Server, and it has one feature that is the reason we use it, and that is you can publish the reports to generate onto this server. And then anybody with a password can just go via the web to this server, to the web interface there, and run the reports. So that's very nice. You can run reports whenever you want. It has a GUI designer like LibreOffice and BIRT. It's not as good as LibreOffice. It's on par with BIRT, I think. It's very quirky. It takes a long time to get used to what different things do, but you can get used to it. And you get some help with designing the queries, but not much. The styling of it works kind of like CSS, so programmers can style things, but I don't think an end user will be able to write a template. Yeah. Pentaho also then has data integration, as they call it, data integration tool, which will do the extract, load, and transform, extract, transform, and load for you. And the business analytics server can do this automatically, I think every 15 minutes if you want, or once a day, or maybe once a week. I don't know exactly. We don't use that. But it has that, so Pentaho does all of it, so that's a good thing to start looking at when you're looking at things. I was also going to have a page of libraries and frameworks, but you see it's kind of short. There's not many Python libraries to help you do reporting. There's basically just a report lab that I can find. There are some tools like Triton that has reporting integration, but it seems to be, as far as I can tell, completely specific for Triton, so you can't use it for anything else. If you know of libraries and frameworks that can help you do extract, load, transform things, for example, that would be nice. I would like to add them to this screen here. But Report Lab works, of course. You can do your queries from the database in Python, and then you get out data and you stick it into Report Lab, and you have a PDF. And you can send that with email to your boss, and you can run this automatically with a cron job at 8 o'clock in the morning, and the boss won't even know that you're not there. Very good. Oops. So, what do we do at Toolbox then about this? How does our reporting look? Well, we obviously then, of course, do it the hardest way we could think of. So we have a very complicated solution. And that's because we started out with very unusual requirements. So we wanted our reporting database to do reports also available for the customer through the web app, because a lot of the reports that a customer would want would be very, very slow to run on our production app. So we thought we're going to run them through the web app from a reporting database. Some of this data is very sensitive, like for example, who owns how many stocks in a company, very sensitive, and that meant we actually needed one reporting database per customer. And we wanted it to be near real time. 10-15 minutes would be acceptable, but not more than that. And this, of course, excludes batch solutions, really. So we have to update it on change. And we also wanted, as the last one, that the non-customer reports should be available to run as needed by those who needed them, right? Instead of being like mailed out once a day or something like that. And that means that we need to do update on change, have one database per customer, and it means we need Pentaho, because that's the only open source solution we could find that will allow us to have a server where we can run the reports, unless we actually write everything ourselves. And we are kind of fanatic about open source. Maybe just, I don't know if you can be kind of fanatic, but if you can, then we are kind of fanatic. Luckily, we had a very good infrastructure, so these high requirements were completely doable for us, because we only have one source for the data, which is our web application, and we have two different databases. We're running things both in Postgres and in ZODB, and the Postgres data is quite often actually in JSON blobs, so it's kind of hard to extract, but this web application is the only source, and it also has event systems, and we're writing it so we can modify it how we want. Because it's based on the SOAP component framework. So basically what was once called SOAP 3 and then Blue Bream, and now it's not called anything. It's just a bunch of libraries that you can use. And we're using them. And it has an event framework. So the objects all send modification events when they're modified. So we had a hook for that already, and we were already using Celery to do asynchronous tasks. So it was very easy for us. And then was the question of how to get it into the database, and we wanted some separation there, so we didn't write directly to the reporting database with the Celery tasks. We instead wrote a RESTful server that would handle that for us. And that means that the extract looks like this, and it's on the application side. So get events on modification, and we just tell salary this modified and what time, and I'll explain the time bit later. That collects the data, makes sure so we don't extract the whole object and dump that out because it contains sensitive information. So we extract carefully what we want, and we send that with a REST JSON call using requests. And the other server, which is called Katie, after Katie Couric, a famous American reporter. She does reporting. Very funny. Yeah, so that's a Flask SQL alchemy thingy with the REST API. It's not that complicated. And we use Pentaho, as mentioned, to make the reports, and the reports they have templates that are quite nice looking from the start. And once you understand how the theming works, you can make templates quite easily. So we get nice templates that use the correct colors and have a little logo in the corner, and you get these graphs. And this is a graph of new customers from a database, from a demo database, and where you can see that we have one incorporation done in 2013, where this project started. So that's where the demo data comes from, and then we have a bunch now in August, which is where I wrote this talk. So, yeah. Not very useful graph, but that's how it looks. Tables look like this. Here we have another nice feature of Pentaho, is that you can, in the reports, have input fields. So here you choose which companies you're gonna make the report for. So you can have a whole bunch of input fields and says, I want actually a report for that sales office during Q3 of 2015. Things like that. The schemas are, of course, star schemas. The reporting database schema is more complex than you would think from this, and this is because this is a star schema, properly, as it should be. But the problem is we have several of them, of course, because we get several different fact tables. But the dimension tables, they're all the same. We reused them between different star schemas, and I could not find anything in any of the papers and blog posts written about star schemas and reporting database that you're not allowed to do this. So we'll see if this bites us in the foot. So far, we haven't had any problem with them. And that means we have several star schemas that are overloaded like this. We've got 5 fact tables and a bunch of dimension tables. But each schema by itself each fact table by itself is its own star schema. And that makes queries fairly simple. So this just selects all the fields we want to use in this report. And then you have a from with a bunch of joins. And this from with these bunch of joins will look the same for every report on a specific fact table. So every time you do a report on some sort of, on the, for example, entities fact, I think that's well used in here if I remember. No, it's work item fact. So work item, which is part of the workflow. When you do a query on the work item fact table, the joins will look like this every time. That means it's easy to just copy and paste for the power user that's starting to learn SQL. So that's good. We also have here, it says, enter entity ID in brackets there. That's the input form you saw before. So that's how that works. But it hasn't been all simple. We have had some problems. One problem is, how do you know if data is missing? And you don't. You can do a little bit of checks. So we have in our admin control panel for the application, we have a tab where you get information about how many entities are, because entities is what we call companies internally, because they're legal entities. So internally they call entities the companies. And we get a list of how many that is in the production database and how many that is in the reporting database. But then you would have to go and verify everything, and if you verify everything, you're actually loading all of the data in the production database, and that will take as long as exporting it. So there's no point in doing that. We just have some very basic checks that everything is there. Otherwise, the way to keep it updated, if you don't export everything and recreate the database every day, is just simply to synchronize a little bit of it at a time. Not only have the updates every 15 minutes or however you do it, but actually every night take maybe 100 companies and sync them, resync everything. So just slowly over a year everything gets resynchronized. Because generally it's not really that important. I mean, if you have 1 or 2 companies that are missing, it shouldn't make a difference for your reports, hopefully. So if it's not completely synchronized, it generally is not a problem. You might actually think that you have gotten 10 new customers when you actually got 12 new customers. But if that makes a difference for your future strategy of the company, then you probably have other problems. Synchronous updates, they're slow, so therefore we do everything asynchronously, but they can come in the wrong order. That's where these timestamps comes in from the events. The event will send information to Celery of what got updated and when it got updated. Celery will also send that information onto the database server that we have, the reporting server that we have. And if the update simply is before what's already in there, we just drop it. So this is another of these problems we discovered with doing the update on change, right? Then you get this kind of problems. And also, I knew that the URL lib doesn't time out by default, but requests, that library is so good, you just use it. You don't have to care about it. Everything's fantastic, right? Well, you know, but timeouts are actually set by the socket library, it turns out. So request library also don't time out by default, which I didn't know. And as a result, we ended up in a situation where the database server would not respond properly to requests because of other bugs, and it would slowly block all our Celery workers, which finally, when all of them were blocked, gave errors in the application that you saw as a customer. And the application essentially stopped working. So that is also a big drawback of doing update on change, because you're changing the application, you can actually introduce new bugs. If you do batch export with separate processes, you haven't modified the application, so you don't have to worry about new bugs. But that's the only one that we had that was actually serious. And for Spain, we wanted multi-threaded servers, but we got massive write conflicts. And these I hadn't gotten locally, and that's because we're on the production server. We're running with a different conflict resolution setting in Postgres than what you're running with default. And the guys who actually know more about databases than me, they said that no, we can't change that. We're not going to change it. So that meant that we needed to implement retries. And we implemented retries both actually at the database server level and the application server. So they both have retries, which means we try up to 9 times now if we get write conflicts. But it turns out the write conflicts, well, that was just part of the problem. Another part of the problem was that we used separate databases before. We had one database per customer. That requirement has been dropped. Very good, because that made the database handling very complicated, especially during testing. And we could not use the Flask SQL Alchemy integration, because you can have multiple databases with Flask SQL Alchemy integration, sure. But you can't, there's no obvious way or easy way to actually create databases on the run. So we didn't use it. And then we missed a little thing called scoped sessions in SQL Alchemy. We just completely missed out on the scoped sessions, which means that our sessions weren't thread safe. That also gave us very strange problems. But we fixed that. Yeah, that's actually all I have to say so far. The slides are available on this if you want to see them. And that's it.
All right. So thank you for that. We have several questions. I guess the first one, which database are you using? You already answered in the talk, but maybe you want to add.
Yeah, so it's Postgres and ZODB. ZODB is the original NoSQL database. It fulfills all of the buzzwords. It's the most buzzword compliant database there is. It's very good, but it's Python only, which is its main drawback.
So, what do you think about using Postgres WAL logs to extract the data from production DB?
Yes, I don't actually know what WAL logs are. Write and add logs, okay. So, yes, so write and add logs, they will tell you what has been written and added and stuff. So you can use that. That's one of the standard and well-known ways of doing this. I think that Pentao data integration, I mean, I haven't done it myself, but as I understand it from the log, from the documentation and from the everything they write in trying to selling this, that integration has support for these kind of things. So if you can point it at the logs and it will actually extract the right thing.
So any recommendation for books or other resources about reporting databases and design them, star schemas?
No, I haven't read any books about it. There's lots of information out there. Most of it seems to be in blog posts. I haven't actually, I mean, star schemas are not complicated enough to write a whole book about it. And so the only real problem with a star schema is to decide which dimensions you should use. If it should be dimension or not, or if you just stick the information directly into the fact table. So you just go by gut feeling there that this dimension, this should be dimension because there's actually several columns of facts that I need out of it, then it might be dimension. If there's only one column of fact you want, then just stick it directly into the fact table.
Do you use in-memory databases?
ZODB is a in-memory transactional database. So that is, the transaction is completely in memory. So in a sense, yes, but in another sense, no. We don't use databases that will load everything into memory generally and use it like that.
So how much time does the initial data import take in your use case? How about updates?
Yeah, so the initial, after we drop the reporting database and we do a full resync, that takes around 2 hours for us. Updates are super quick because any update that goes is generally, it's just very simple. So we just load an object into memory on the application side, and since this object was recently modified, it generally already is in memory. So that's very fast. Just make a JSON dictionary out of the data we want, dump that on the server, and then it extracts it and dumps it on Postgres. So that's very fast. What takes time is actually loading the data from disk when you do a full synchronization.
So are you using something like materialized views?
No, I don't even know what that is.
What do you spend most development maintenance time on?
Writing tests and getting the tests working properly with the database. We do one thing that we might actually change because it's blocking us from now using the Flask SQL Alchemy integration, which is standard, which we can use again, at least in theory, since we're not creating databases dynamically anymore. And that is that nobody is creating a database for testing and then dropping it at the end of the test. I can't find any example of anybody who does that, but I tried, and even though you closed all the sessions, you discarded all the engines and connections, everything is closed down, it will say, no, I can't drop this database because there's a session open. I can't find that session, I don't know where it comes from. It's not one of the ones that I opened during the tests. So it's things like this, and just setting up the whole test framework, that's taken a month, I think. That was a pain in the ass.
Or this is more like suggestion that you can use Jasper reports or reports?
Okay. Jasper reports, I should look at that then.
What kind of timestamp do you use? Distributed?
No, I just used the timestamp for when the event happened, so it's time. Very simple.
And I think the last one, have you considered big data query engine like Impala or Apache Drill?
No, we haven't really. I mean, we're using quite a lot of Amazon stuff, so Amazon Redshift would have been a possibility. But again, we were from the start supposed to have very sensitive data in these databases. Now we don't really, but we were supposed to, and that meant that we didn't want to put this on Redshift or anything other than that. We wanted to use our own database and have complete control of it. So we just went with Postgres because that was the obvious solution. We don't really expect to get huge amounts of data so that these reports will start taking half an hour to run. So we don't. That's probably not going to happen. It would be nice if it did, but.
Yeah, all right, that's it. So thank you very much for your talk.
Thank you.